In this video, I am going to find the inverse of this function if it exists. This given function f of x is equal to negative 3x squared plus 7, by the way, does not have an inverse. I'll show you graphically why it doesn't have an inverse. If you sketch the function, this is how it looks like. It's a parabola. Okay. Now, remember, for a function to have an inverse, it must have to be one-to-one function. What does it mean for a function to be one-to-one? It means that if you have two different x values, it will give you two different y values. This function fails to pass that test. That means I could give two different x values, it will give you the same y value. Why not just look at this simple point at 0? Okay, here y is 0 here, y is 0 here. So for these two x values, y is 0. So I will have a scenario where I will have the following situation. I have a, let's label this point a comma 0, and it's a parabola, it's symmetric, so this is going to be negative a comma 0. I just picked it. It's going to be, by the way, if you simplify it, it's going to be square root of 7 over 3. But let's call it a and negative a. So you will have negative a. So what's happening? This is your domain and this is your range. So these are all the x's, these are all the y's. So from here you are mapping a to 0 and negative a to 0 as well. So remember, the function f takes you from here to there. But f inverse, by the way, is going to start here and take you there. So now if you go the other way, what's going to happen? You will have f inverse of 0. That means you are going to have to map this 0 somewhere here, which is going to be, is it going to be a or negative a? That means technically what's happening is that one value 0 is getting mapped to two different values. That is unacceptable. That is violating the definition of function. So that's the reason that this function doesn't have an inverse, because the inverse function, if there were to be one in this case, it would violate the definition of function. Now there is something else, what we call horizontal line test. So we call it horizontal line test for finding the inverse. So what it is, you are gonna draw a horizontal line anywhere on the graph of the straight line, a graph of the function. You are gonna draw a horizontal line anywhere on the graph of the function. Now if that horizontal line intersects in more than one point, then this function does not have an inverse. Once again, if you can draw a horizontal line on the graph of a given function, so this is the function and this is the graph of that function. If you can draw a horizontal line anywhere on the graph of a function where it intersects the graph in more than one point, where it does, as we can see right here, then the function does not have an inverse. Of course, x-axis is a horizontal line too, right? So this intersects in two locations. Another example that this function fails to have an inverse. Now let me summarize what I talked about. Basically, to determine whether a function has an inverse, you have to either go through the one-to-oneness test just by doing the mapping, which is numerically finding it out, or you can do the horizontal line test to find out whether the graph of the function has two intersecting points with the horizontal line. Okay, so these are the two ways to find out whether a given function has an inverse or no. Now a general note that I would like to make here, or general point I would like to make, if you have a function like this, but the exponent of x is an even number, like 2 positive number, let's say 2, 4, 6, 8, 10, then these functions won't have an inverse. Okay, that won't have an inverse because the even power is going to cancel the negative values and convert it into positive. So even power is gonna cancel the negative and convert it into positive. Like for instance, for simplicity, I'll give you an example here. Y is equal to x to the power x squared. Let's use the easy one. If x is -1, y is -1 whole square, which is 1. If x is +1, y is gonna be 1 square, which is 1. So regardless what these two values are, both of these are getting mapped to only one, which is 1. And you can use like -2, +2, you'll see that it goes to 4, both of them. So this mapping violates the definition of function when you go the other way around. That means you try to find the inverse function. Anyhow, I hope that this discussion was helpful. Thank you very much.